So let's talk about low-cost hardware. So how many of you guys are actually designing or building your own sensing hardware? One or two of you maybe? Or have worked directly with these, installing data loggers, this kind of stuff? Well, that's still designing your own hardware, not necessarily exactly the way that we're doing it, right? And if you guys are working managing this many data loggers, then this is also the same direction. Okay, so some of these logos may be familiar to you. In the last 20 years, there's been a really huge decrease in the cost of computers and in the availability of these kind of hardware, like the small computer chips, and think about sort of the power that your cell phone is versus what it was, 10 or 15 years ago, right? All of this kind of computing hardware keeps getting faster and smaller and cheaper. So alongside this change in the availability of hardware, there's also been a lot of developments in software. So some of you probably recognize this from yesterday. This is the Python logo. R is also another big free programming language, and Linux is basically an open source computing initiative. They do the hardware or the software that underlies a lot of these open source projects. And then on the hardware side, you maybe have heard of Raspberry Pi and Arduino. These are two of the bigger, I guess, projects that have been releasing open hardware in the last years. So more specifically, there's, of course, a lot of different platforms that you can use for environmental monitoring stations. Some of them are from commercial companies. Some of them are from these sort of open source platforms. And of course, as with anything that's built in these small electronic kind of things, there are also many different copies and knockoffs and other small projects that come from all over the world. The two that Bodo and I have worked with most, and that I'm going to focus on today, are Raspberry Pi and Arduino. So these can sort of be broken into two main functions. The Raspberry Pi is usually for processing or collecting the data, and the Arduino is generally for connecting directly to the sensor. So the Raspberry Pi, how many of you guys have heard of Raspberry Pi before? A handful. Okay. So, well, I have this. No, I don't have one up here. You have one. Okay, cool. So the Raspberry Pi Foundation was started in the early 2000s with the goal of having small computers for educational purposes. So their idea was if you can make these small, cheap computers and distribute them to classrooms, people would be able to learn coding, and kids would be more aware of sort of what is actually happening when you use a computer and how possible it is to actually access your hardware and do something with it. And since then, there's been several different generations of them. This is sort of the Raspberry Pi 3, and then this is the newer, smaller one, which is the Raspberry Pi Zero. This is maybe, I think, 30 euros now, and this is something closer to 5 or 10. So the goal is to have these things be really as low cost as possible, but still powerful and flexible enough to do a lot of different projects. If you look up Raspberry Pi projects on the internet, you're going to find everything from running a car stereo to being a data logger to running an aquarium pump, like anything you can really think of that you need a computer that's just always on and not using much power to just be there and be customizable. These are basically the equivalent of a very, very small laptop. So you can plug in an HDMI cable, you can plug in a keyboard and a mouse, and you could use it just like a computer. It wouldn't be the fastest computer that you've ever used, but you can use it with a mouse and a keyboard just like you're used to. You can also, of course, just access it through command lines and install any sort of program that you want on there. The nice things about them from a sort of hardware standpoint is that they require very little power, and they can access Wi-Fi or Bluetooth, and yeah, they're very flexible, so they're really good for being where you collect data from many different sensors and put it all together and send it over the internet. So when Bodo and I are installing sensors, generally we have an Arduino or some other kind of small hardware that connects via USB cable, and we have 3 or 4 sensors that all send their data here, and the Raspberry Pi is responsible for taking all that data, putting it into one file, and uploading it through Wi-Fi or through a SIM card to us. So this is sort of like the master computer that takes all the data from different places. The Arduino is sort of, it started with a similar goal, that it was to make low-cost and educational devices, but they weren't so interested in having sort of a desktop environment or being like a little computer. They were much more interested in creating microcontrollers. So microcontrollers is basically how you access a sensor. So if you just have a small piece of hardware like an infrared thermometer or a temperature sensor, something like that, something has to take those electrical signals and translate it into numbers. And the Raspberry Pi can do that in some cases, but it's not really optimized for that. It's not meant for that. The Arduino is meant to just be a little board that controls 1 or maybe 2 environmental sensors. So this is sort of the other end, and it's very much on the hardware side of things. So you can't attach a keyboard or a screen or something to an Arduino. You can't program it directly. You have to work with it over the command line and send sort of much more low-level commands to get it to work. Basically, each board is only able to do one task at a time. It just does one thing. So it says, every 2 seconds, read the data from this little board and tell me what temperature it is. So it's just always doing the same thing over and over. It can read the temperature and then send the temperature back to the Raspberry Pi. It is also open source, and it's been around for a while, so there are a lot of different sensors that are very easy to interface with Arduino. And power consumption on these things is even lower than a Raspberry Pi. You could run one of these on a battery for years if you had it turn itself off and then turn it on every minute to take 1 second of data and then turn itself off again. It's really meant for this kind of hardware and data logging side of things. So, how does this work in terms of environmental monitoring? I'm sure some of you are quite aware that these commercial products can be quite expensive. I just found the first 2 that I saw on Google. This one of a weather station had a price tag of 7,700 euros, and this one for a weather station had a price of 10,000 US dollars. So this is not a cheap piece of equipment to buy, right? And I can see that they have sort of a temperature humidity thing in there. There's maybe wind speed and a couple other things in there. But these are also things that you can build yourself. So, for example, if I want to look for a temperature and humidity sensor, the sensor is $5. I can order that tomorrow, and it's not particularly hard to interface. You have to do a little bit of your own legwork to come up with the right connectors and put it into something like an Arduino that actually reads the data. This you can't just plug in via a USB port to your computer and get the data. You need something in the middle to translate it. And that's what the Arduino is good for. The point I wanted to make is that the price of these things has also dropped a lot in recent years as they've become more and more available. This is another example. This is the one that we use to get pressure and temperature. And this is extremely accurate, like 0.01, what is it, down to 1 meter of elevation accuracy. So it's a quite accurate pressure sensor, and it's not a really expensive piece of hardware, right? From the water side, you can also get in like a total dissolved solids sensor, and this is also something that's, quite affordable. So there are just a ton of these different things. I couldn't even open this whole list. I just had to screenshot a chunk of it. If you start searching for what kind of environmental parameter you want to measure, along with maybe the keyword Arduino, and you'll come up with many different sensors that people have used for all sorts of different projects. And while we're not building, this whole fully calibrated weather station setup, it is something that you could investigate if you have certain standards that have to be met, whether this kind of hardware would be able to duplicate them or not. What you don't get when you do it like this is you don't get a big support package, and you don't get everything pre-built for you. So you have to spend some time and some knowledge to actually construct it yourself. So, for example, one of my sensors just looks like this, right? It's me wiring two pieces of hardware together. This is a thermal camera, and this is the Arduino. So together I can then take thermal pictures of things. But this is not coming in like a nice box that I can just plug it in and the software already works, right? So I have to do all of this myself. And if you thought yesterday's computer code was a little confusing, this is really the next level of saying we got to put a positive voltage on this pin and a negative voltage on this pin. So it's another level of software development as well. So you have to design basically everything yourself about how often the sensor measures, which variables you store, how often you transmit the data, etc. On one hand, this is a lot of extra work. On the other hand, it means you can control exactly what data you're getting. So if you only want data every minute, then you can have the sensor only send you data every minute. If you want to average it every second, you can have that data. So you're not limited by what somebody else has decided is the right way to run this sensor. You're building it yourself. I just wanted to put these, of course I'm going to put all these slides online. You don't have to look at all these links. There are a ton of different learning resources for both Raspberry Pis and Arduinos, and sort of any sort of sensor that you might want to build yourself. There's resources online. I also have self-taught myself how to construct these sensors, and it took some time, but it wasn't impossible. But it definitely was a little bit of trial and error for some of these things. And just to also talk about the final level of customization, that you can also have your own PC boards printed. So if you know exactly which sensor you need and which data logger works well with it, you can make a quick design and send it to one of these companies, for example, this one in China, and they will mail you back a little PC board, which is your data logger and environmental sensor. And it's like $2 a piece or something. It's really cheap to get these circuit boards printed. But this is a whole another level. It's not taking off-the-shelf hardware and putting it together. It's designing it from scratch. So I just wanted to make the point that this is possible. Whether or not it actually makes sense for you, we decided it didn't make sense for us because we weren't making hundreds of these things. But if you're going to install a larger network, then having sort of exactly the hardware that you need, it's something that is possible. All right, questions about this? We can leave them up here too in the break. So you might have noticed that there's this huge wall of text going down here. I just have a couple of these devices, so I figured I'd plug them in and show you what this actually looks like, what the data looks like. So this little thing is a GPS. It's a small antenna and a very small GPS chip. And this is on the low-cost end of GPS. I'll talk about a little bit more why we're using this GPS in the afternoon session, but just to show you what the raw data actually looks like. So my little Arduino code is just saying everything that the GPS chip sends me, just print it on the screen. And this is what I would have to write to some file and save to my Raspberry Pi and send back to my computer. This GPS data is not the easiest to understand. It's basically telling you how many satellites you have in view, how high above you they are, which is useful for figuring out where you are, but also for understanding how the GPS signal goes through the atmosphere, how it reflects off of other surfaces. And yeah, we'll talk about this a little bit more afterwards. So that's what the GPS looks like. I also have a couple other ones here. This one, let's see, is this long enough? This one is a LiDAR sensor. So what a LiDAR sensor does is it shoots out a little laser and measures how long it takes for that signal to come back. And based on that, it computes the distance. So basically how far away things are. And this is a little bit of a longer code. It's not so long, but it's a little more complicated. But this is, maybe I'll make this bigger here. Every second it takes 10 measurements. It tells me I measured 10 times. What's my average distance every second, my signal strength, and the temperature. So there's also an air temperature sensor in here. And now if I go and sort of put my hand in front of this, I guess it's a little hard to see. You can see it's down now to 7 and 10. And I can go against the wall over there, and it's more like 3 meters. So I can measure things like distances and temperatures very quickly. And this is what we use to sort of point down at a river and measure how quickly the river height is changing over a very short time span. Let's see if we get this third one to work. So the third one I have here, we can pass them. There's not much to see with this one because it's painted. It's just a LiDAR here and a little camera in a weatherproof box. But we can pass this one around here. This is the GPS and the antenna. So the third one I have here is a thermal camera, which is the sort of the touchiest one to work with. So let's see if we get this to work smoothly. So, COM73. So this should now open up a little image. So this is now basically the temperature that this thing is seeing. And if I put my hand here, it should in a couple of seconds. This one only measures every few seconds. It starts to see this warmer area here where my hand is in the way. If I put my hand all the way in the way, it should eventually be this big yellow thing. So the yellow stuff is brighter, warmer temperatures, and this grayer stuff is cooler temperatures. So my skin temperature is warmer than the sort of background temperature or the temperature of this ceiling. So when I put my hand in front of it, it takes a second to update itself, but then it eventually should give me something that looks like a hand in front of it. Let's see if it works with spreading my fingers out there. As I said, this is the more difficult sensor to work with since you're getting many, many data values that all have to line up properly to make a grid. So it does work, but this one's a little bit trickier to work with. There we go. So we got a bit of a hand there. To hold my hand very steady for this to work. There. Perfect. So that's what I wanted to show you with what this data actually looks like. Let's see. So if you see this is the here, if I move this up, this is what I'm actually getting. This huge block of numbers is what all this sensor is giving me. And I have to do some extra work to turn that into a grid, which is then actually a picture. Once you have it figured out, so for example, I have one of these pointing at a river, I can see if there's different parts of the river that are warmer or colder, and how that temperature changes over bigger regions throughout the day. So this is also something that we've been using. And I guess I can pass this one around too. This one looks a little bit flimsier, right? Yeah, so that's the demo I wanted to give with the open source hardware stuff. Do you guys have other questions about this?